So, to do this problem, we're going to have to use factor theorem and remainder theorem. We'll start with the factor theorem. It says that x plus 1 is a factor of all of this. So, what we're going to do is let this be 0, because f of negative 1 is 0, and then we put in our equation, plus nx minus 5. So f at negative 1, because it's the factor, we're going to substitute x equals negative 1 into the equation. So 0, 6 times negative 1 cubed, plus m times negative 1 squared, plus n times negative 1 minus 5. And what we end up with is it's going to be negative because it's an odd degree or an odd exponent. So it's going to be negative 6 plus, so negative 1 times negative 1 is positive 1, or just m, minus n minus 5. You can combine negative 6 and negative 5. It's going to give us negative 11 plus m minus n. Add 11 to both sides, and we get m minus n equals 11. That's going to be our first equation. So equation 1. We're going to do pretty much the similar thing using the remainder theorem. The only difference, instead of equaling 0, it's going to equal negative 4, and we're using positive 1. So negative 4 equals 6x cubed plus mx squared plus nx minus 5. And we're going to substitute in x equals positive 1 in this case. So negative 4 equals 6 times 1 cubed plus m times 1 squared plus n times 1 minus 5. Negative 4 equals 6 plus m plus n minus 5. We're going to combine 6 minus 5, that's 1, plus m plus n, and I'm going to subtract 1 from both sides. And I get negative 5 equals m plus n. This is equation 2. Now, what we're going to do is subtract the two equations. So we got equation 1, we're going to subtract equation 2. So we got 11 equals m minus n over negative 5 equals m plus n. You're going to subtract both of those. So 11 11 minus, okay, so we're actually adding these, then we don't have to work so hard. So 11 minus 5 is going to give us 6. M plus m is 2m, and negative n plus n is 0. And so we have 2m equals 6, divided by 2, divided by 2. M is going to be 3. That's good. We just need to do one more thing. We still have to find n. That's not so bad. I'm going to use equation 1. So equation 1 is 11 equals m minus n. And I'm going to substitute m equals 3 into the equation. So 11 equals 3 minus n. And so I'm going to subtract 3 from both sides. I get 8 equals a negative n. So you can get rid of a negative n by timesing by negative 1. Multiply by negative 1 both sides. And I get negative 8 equals positive n. Okay, let's do a really quick check. And we'll put it back into, let's put it into an equation and see if it works. So I got 3 minus negative 8. That's like saying 3 plus 8, 11 equals 11. Okay, so that works out.